going to load the program, and it's now loading the data set that was last analyzed. So I'll just expand it a little bit. And you have two windows here, top window and the bottom window. And you can expand this. And this is a data set of teeth that are quite a large data set over several months, as you can see. And you can expand them. So the idea is to mask the teeth. This is all supposed to be the same tooth here. And you can see that the images don't always match. And I guess this is because of the way that they're imaged. I'll take an example, maybe this one. So these teeth here are different sizes, and you can see that this doesn't exactly fit the tooth. So what I can do is I can change the sensitivity here to increase the what I think is the tooth. Not that I know much about teeth. And then I can set a mask that I think fits that tooth. So I can set the mask, and now if I click here, right click on the image, it tries to get an idea of where the plaque is, which is the red area. Now if you don't think that that is plaque, you can remove those areas by this black area setting the superpixels. So the idea here is we use superpixels, very large pixels that is, and we try to approximate the tooth size. Now clearly these ones up here aren't considered to be plaque, and I don't think this one is either. So I'm going to remove those. So if you're unhappy with the resolution, you can change the number of superpixels here. So let me make it 1000 and recalculate. And what that will do is it gives you more resolution for where you think the real teeth are. So let's say you don't think these ones should really be red. I can remove them. And same here. If you don't think that one should be red. And that's sort of a principle here. And if you think some of them should be green that are not green, you can do the same. Let's say you take this area here and you think, well, that's really not plaque. So you can go in there and you can create a few pixels that will be removed from the calculation. When you save that, that map is now saved. So if you now move to the next one, and you can see that you don't think this is really integrating all of the tooth into the area, you can change this background level. And you can then move down to the next one. And one of the features is that you can move the image to sort of fit a little better into the model. If you're unhappy with the fit, and this one doesn't look great, so here I can compact the image a little bit. Sometimes it's hard because the image wasn't collected exactly in the right way. So that's sort of not too bad. But again, I think these areas here should be incorporated, and so I would make this like this. Anyway, I'm not going to go through the whole thing here, but you can see the principle here of establishing the baseline. And then down here, just to show you, if you click on here, you can plot out the sample, and let's say you want to plot total area or red area only or green area, and that will plot all of the samples that are here. So I'm just going to show you sort of an overview there. And you can change this to a cat, and this will reset the teeth to be approximately cats. So that's the general goal of this software package, that you can pull up any image, you can increase the collection efficiency, and if you're not happy with the area, say, of green, I can change the green pixels. If I set the red channel, I can set the red channel to increase here. And if again I'm not happy with that, I can change this area here, and all these areas will now be incorporated as red areas. And then if I set the green channel intensity, I can look at all of them, and let's say I want more green channel here, then I would just move these. And again, you can use these larger superpixels, or you can make the superpixels smaller by changing this number here to whatever number, recalculate, and you will see larger pixel area. And again, I will reset them here because I did a recalculation. But again, if you use the smaller pixels, you'll see that it takes a little bit longer to establish what you might consider to be more accurate reflection of that tooth. Anyway, that's White Fang. Well, it's not a very brilliant name, but what can I say?